introduction to operating systems is regarding the distributed systems. So distributed system is a network of independent computers. Here, independent computers are interconnected, and there are mainly two types of distributed systems. One, what we call a centralized distributed system, where there is one server, and to this server multiple clients are connected, and all the clients interact with the common server. So the server will have all the computing facilities and the storage facilities. Clients will have a smaller facility, just sufficient to interrogate with the server. So the client will send a query to the server, and server in turn gets this query and then looks for the solution and sends back the solution. So that's how a distributed system started working. So one system can be made useful to multiple clients, and then we have another type of distributed system where each client is independent entity in itself, not like a client server. The major role is played by the server. Here, each client is client as well as the server, and they are interconnected to one another. So we call it a peer-to-peer connectivity. So here, the interconnection may help in sharing the data, may help in sharing the results and all that. So we have the positive part, then along with that there has to be some negative side. So challenges are there like consistency, then communication latency and all that. So just looking at some of the challenges a distributed system faces is, one is a heterogeneity. That means each client in the distributed system need not be homogeneous with other systems. It can be uh, differently made. So heterogeneity is one common problem. So whenever two systems are trying to communicate, then it has to have a common protocol, and if they are working in different platforms or different protocols, then it becomes difficult. So we need to have a translator in between so that a common protocol can be defined and all that. Then comes the security issue, because now we are allowing others to enter into our domain. We are allowing others to enter into our region, and by allowing others to enter into our region, we are uh, opening up with a threat. So there will be definitely threats. So there will be security issues. We need to be very much serious about how to maintain the security and all that. In spite, we are allowing others to interact with our system, because we are dealing with distributed systems. So instead of having one system do all the work, we can distribute the works to various systems and make sure that all the systems can do the works parallelly and come out with a solution at a faster rate. So for that we thought of having distributed system, but this interaction is definitely going to create a security issue. So we need to be very serious in this. Then fault tolerance, yeah, there can be faulty systems on the way, so there has to be a problem. Next thing will be the concurrency problem. When we have resources that are being shared among the multiple systems, then their concurrent request can occur, and because of this, we do have problems. Usually, when resources are being shared, mutual exclusion is what we need to maintain. So make sure that any given time only one client can make use of the resources and others should keep waiting till the resource is free. But it may happen that two systems look at the resource at the same time and both of them find that they are trying to see the resource which are free, and both feel that they are free and they start using them. And because this action happens in concurrence, so both of them start using the resource and that creates a problem. So we need to ensure that in spite of concurrent activities, the whole system should work in order. Then a question of scalability, how many of the systems can be connected under this distributed system. So what would happen if the number of systems increase, how things change, and about openness, about mitigation, migration, and load balancing and all. So when uh, we are working with the multiple systems, each system is provided with some sort of actions, and if one system wants to move out of the distributed world, then who should take care of that particular load? So there has to be some load balancing protocols and all that. So there are many challenges when it comes to distributed system, but along with that, there are many advantages also. Then looking at some special purpose systems for which we need to create operating system on tailor-made basis. So one is a real-time operating system. Yeah, real-time. That means the response time should be as small as possible. So if we are trying to work with a system and if that system operating system is very slow, its response time is very slow, then we miss the bus. So to make sure that the response is fast enough so that the real-time activities can be taken up, then we should ensure that the size of the operating system is as small as possible. A tiny micro or a tiny operating system is what is required to ensure fast response, no delays, and all that. So there are basically two types of real-time operating systems. One is a hard real-time operating system, and the other one is a soft one. So the hard one is one which where the deadlines are critical, so there is no chance of delays and all that. When it is said that after 10 units of time the result should be ready, that means it should be ready by exactly 10 units of time. Cannot go on to the 11th unit of time also. There is no flexibility, so the deadlines are highly critical, and if anything goes beyond the deadline, then catastrophe can occur. So this hard RTOS enforces strict timing constraints where missing a deadline can lead to catastrophic failures. On the other hand, the soft RTOs are flexible. So the example for hard RTOs can be robotics, whereas for the soft RTOS is streaming. So when you are streaming the live videos and all that, sometimes it may get delayed, but what we actually do there is instead of streaming regular videos, we stream in terms of packets. So one packet at a time, we just keep on passing on. So the video works at a slower pace compared to the data being transmitted. So for 1 second of video, it requires say 30 frames, and 30 frames, some number of pixels and all that. That is for 1 second, and this 1 second duration of the data, if it can be transmitted in say milliseconds, then everything works smoothly. But now and then something may happen, it may be delayed, so we find that the videos sometimes get stuck, but doesn't make much difference. So that's real-time systems. Sometimes it may get stuck, but doesn't make much difference. Yeah, we need to wait till the video continues. Okay, not a big issue, but in case of robotics, like examples, this type of delay cannot be tolerated. That is a hard RTOS, soft RTOS. So there is something in between which we call firm RTOS, where it's a balance between the two ends. So deadlines we can miss, but missing deadline cannot create much problems. So that's some details about the special purpose system. Then we have embedded OS. So that means the operating system is embedded onto the processor itself. That means the whole operating system should be dumped onto an electronic memory, that is a RAM or EEPROM or EEPROM, whatever it is. The size of the memory will be small, so that the whole operating system should be designed such that it consumes very small space. So mostly only kernels are used for such a operating system. So it commonly used in case of IoTs and the systems which are controlling the various components of the cars or automobiles. Any such things, they do require an embedded operating system, because the whole operating system should be embedded onto the processor itself for fast response and efficient response. Then we have multimedia operating system, which is mainly worried about the bandwidth and quality of service management. Now looking at various environments that a computing system can have, it may be a personal computing environment, time sharing computing, or client server computing, distributed computing, grid computing, cloud computing, cluster computing, various types of computing environments we do have. So starting with our traditional desktop or server, then we have mobile operating systems, where it can be iOS or Android. Now it makes use of input output, better sensors and better actuators, touch screen and sensors and all that are implemented into this. Then we have cloud. Cloud is a Best example for virtualization. If we are implementing a project, say an on-site project, then it consists of so many various components like applications, data, runtime, middleware, operating system, virtualization, servers, storage, networking. So if we implement it on site, then everything we need to manage. But if we make use of cloud, then there are many ways we can get the service from the cloud. One is infrastructure as a service, wherein virtualization, server, storage, networking, these are taken care by the service provider, whereas the upper layers we need to manage ourselves. If it is the PAAS, then we only have to worry about application and data components. Rest of the things is taken care by the service provider. And if it is software as a service, then all the components are taken care by the service provider. Then the environment can be looked into this triangle where we have what we call cloud, which is consisting of data centers. So there are thousands of data centers, and then we have under the cloud we have fog, so which are made up of nodes. So there are millions of nodes under thousands of data centers, and each node consists of devices, so which we can call an edge. So cloud consists of fogs, fogs consist of edges, edges will be having devices. So there are thousands of clouds, there are millions of fog, then there are billions of devices in the overall system. So that's how this whole system is arranged. So that's something to do with introduction to the operating systems. The first part, we have many issues to discuss, so keep watching. Thank you.